Okay, so we're back now to do the parallel circuits. So over on page 724, I had asked you to do numbers 32 to 35. So here's number 32. 3 resistors, 9-volt battery, R1 is 13.5, R2 is 9 ohms, and R3 is 6.75 ohms. These might seem like horrible numbers, but they're really not that bad. And the question wants us to find the I's and R total. So in a parallel circuit, to find R total, you do 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And remember I said I want you to actually show me the fraction work here. Show me you can find a common denominator so that when you walk across the stage, I know your high school diploma is actually valid. So 1 over 13.5 ohms plus 1 over 9 ohms plus 1.6 over 6.75 ohms. Kind of crazy numbers, but if you notice, 6.75 is half of 13.5, and 13.5 is half of 27. So the lowest common denominator is 27, where this becomes 2 over 27 plus 3 over 27 plus 4 over 27. So not that bad at all, because the top adds up to 9 over 27. So 1 over R total is equal to 9 over 27, which is really 1 over 3 ohms. So R total is equal to 3 ohms. That piece is done. Then if you remember, in a parallel circuit, voltages are all the same. So if V total is 9 volts, then so is V1, V2, and V3. So if we have V1, V2, and V3, and we have all the R's, then we can find all the I's. So I1 is just going to be equal to V1 over R1. So 9 volts over 13.5 ohms. That is 2/3 of an amp. I2 is V2 over R2, 9 volts over 9 ohms, 1 amp. And I3 is equal to V3 over R3, 9 volts over 6.75, and that is 1 1/3 amps. And these three should add up to give me back my I total, which if we did it 9 volts divided by 3 ohms would be 3 amps. And this adds up to 3 amps. So we're done. We're good. Question number 33 tells us there's 2 resistors. Well, they actually say a light and a heating coil or something, but I still draw them as resistors. Total voltage from the battery is 9.75 amps. Total potential difference of the battery is 45 volts. 7.5 amps is flowing through R2, and it wants to know what are R1 and R2. Well, in parallel, voltages are the same, so this 45 volts is also V1 and V2. So if we have V1 and we have I1, we can find R1. So R1 is equal to V1 over, I1. So 45 volts over 7.5 amps, that should be 6 ohms. And we also can find our I2 because we have total current is 9.75 amps, I1 is 7.5 amps, so I2 should be I total minus I1. So 9.75 amps minus 7.5 amps, I2 should be 2.25 amps. And so now we can find our R2 because it's just going to be V2 over I2. So 45 volts over 2.25 amps. And I think that's 20 ohms. Okay? I don't know if the question asks for R total, but if it did, you could just do V total over I total. V total, 45 volts. I total over 9.75 amps. And that's going to be 4 point something that I don't want to do in my head. 4.615 maybe, or something like that, ohms. Whoops, better move it so you can see I did write the ohms in even though you can't see. All right, so that's number 33. Number 34. 34 is a circuit containing a 12 ohm resistor, and it has 3.2 amps of current flowing through it. The second resistor that we don't know has 4.8 amps of current flowing through it. Sorry, I'm trying to get it to focus, but I don't know that it is. And I want to show you a new technique or a different technique of how to solve these. You don't really need it here because this one's pretty simple, but we're going to use it when we get to the complex ones. And that technique is to create a table. So I've created the table down here. In the table, it always goes V, then I, then R, going down. And there's always a column for the totals. So start with V total, I total, R total. And then a column for each of the resistors. So V1, I1, R1, V2, I2, R2. So once you create this, then you go and you fill in what you know. So they tell us in the question that R1 is 12 ohms, so we put it in there. Tells us that I1 is 3.2 amps, so we put it in here. And it tells us that I2 is 4.8 amps, so we put it in here. Now, the cool thing about the table is it's like a Sudoku puzzle. In a Sudoku puzzle, if you have a row or a column where you're just missing one value, it means you can find it. So here we have I1, we have R1. It means that we can find V1. And we can by just doing V equals IR. So 3.2 amps times 12 ohms. And when you multiply this together, you should get 38.4, I think. You're not here to confirm for me. I think it's 38.4 volts. Okay? And we can also get I total. If I2 is 4.8 and I1 is 3.2, then I total, you can, in parallel they add, it should be 8 amps. Okay? Now also though, in parallel, voltage is the same. So if we have one voltage of 38.4 volts, then it means we know the other two voltages. They both must be 38.4 volts. And now we can find R total and R2 by dividing. So 38.4 volts by 4.8 amps is 4 ohms. No, excuse me, 8 ohms. I did write 8, even though I said 4. And 8 into 38.4, 4.8 ohms. Done. Okay? So the table is quite nice. The only work you would have to show me for the table is the 1 over R total stuff. Whenever you do 1 over R total, I'm going to want you to show me the work because that's usually where people screw up. So let's take a look at the last question, number 35. It has 3 resistors, R1, R2, and R3. And so this time our table would have 4 columns. It would have total column, 1 column, 2 column, 3 column. And please, when you build your table, always go in order of VIR. It just makes my grading life easier. I always have someone that decides in every column to switch up the order. It really causes stress on the couple of brain cells I still have working. All right, so create your table and now fill in what you know. So in the question it tells us I total is 4.8 amps. So we fill that in here. Tells us I1 is 2.5 amps, so we fill that in here. Tells us I2 is 1.8 amps, so we fill that in here. And it tells us R3 is 108 ohms. Okay? And so we can find our I3 because we have I total, I1, and I2. So taking 4.8 minus 1.8 is 3, minus 2.5. So I3 must be 0.5 of an amp. Now that we have I3 and R3, we can get V3. Half of 108 is 54 volts. Okay, so we have our 54 volts. Now we have to stop and say, oh wait, but this is in parallel.